Probably out of batteries. Okay, now that was what we did on Monday. From here, you can solve the last triangle two ways. You can do law of sines again. Sine of 90 over this equals sine of 67 over h. Or, because it's a right triangle, you can just do SOHCAHTOA. What angle do we have to work with in that triangle? Slow down. We have 67, right? H is which side from 67? And which side is this? Which trig function uses that? Sine. So you could have done sine of 67 equals opposite over hypotenuse. Or you could have done law of sines again. It's up to you, really. Somebody work that and tell me what you get for h. Excellent. Excellent. Excellent.
How would you figure out
Oh, so, well, once you have this piece, you have to figure out which trig function you're using. So when you start with an angle, so we chose 67. I guess you could have subtracted and used. Oh, you just multiply by, yeah, you multiply by 523.1. Yeah. All right. Questions on that? Yeah, 25-ish. Today, we are going to keep using law of sines. There are literally 3 more problems in this section that I want to cover. 3. We're going to talk about that briefly, and then we're going to do the law of cosines. The whole thing together, even though it's pretty much 2 sections, shouldn't take that long. So let's just get it done. Questions about this DOM before we move on? Okay. What is the area of a triangle, someone? You probably needed that yesterday. 1/2 base times height. Here's a standard triangle with random sides A, B, and C. You don't have to write this if you don't want to. With random sides A, B, and C. And are we in agreement that 1/2 base times height, which I just went ahead and made little b so that it matched our formula, equals the area? Any objections to that? What if you don't have the height? Here's a new formula I'm going to teach you for area of a triangle. What if, brainstorming here, what if I, using my eraser tool thingy, erased, yes I am, that part of the triangle. I erased it. Now I have a smaller right triangle, don't I? But I still have h. I accidentally covered it up, but this side is now h, just like it was in the big one. What would sine of A be? Using SOHCAHTOA, what would sine of A be? Sine of A equals h over c. Now, if the height was something we didn't have, we would want to solve for it and substitute it. So solving for h in that formula, if you multiply by c, won't that give you c times sine of A equals h? Good. That's the correct answer. Very good. So if I take this back away, and I'm going to substitute that into my formula. I'm going to take out h. Oh, man. And I'm going to plug in what h equals. C sine A. The area, oh darn it, I have 2 big A's, but the one on the left is area. The area of my triangle is 1/2 BC sine of A. Yep. It's a B, I just accidentally wrote for it. What? 1/2 BC sine A. Now those letters might not always match up with, like, it might be HJK, so how do you know which is which? Well, notice, is little a in this problem at all? No. It's the angle and the sides not opposite that angle. So for A, it would be sides B and C. If I was given angle C, no big deal, but then I would just use sides A and B. If I was given angle B, I would use sides A and C. So the actual letters aren't so much important as an angle and the sides on opposite sides of that angle. The 2 adjacent sides. Let's look at one. I wish I had a picture, but I don't. So we're just going to look at one. Well, so there's the formula. We just said it. The only reason I wrote it 3 times was to just reiterate the fact that it doesn't matter which letter is which. You just take, anyway. Okay, so 33. What is my angle? Well, They kind of made this easy for you because they only gave you the necessary information. They could have given you all three sides so that you would have had to choose. If they had given us little a right here, you should know that's the one you don't need. You need the other two sides and the angle. But these, you just plug them into the formula. The area of this triangle is going to be 1/2 BC sine of A, that huge product. You just punch it in your calculator, bang. Somebody punch it in and tell me what you get. Two, 9, 7. Will somebody verify that? What are my units? Keep going. Way to go. Feet squared. Anytime you have area, your answer should be in units squared. Volume is cubed, but that's not here nor there. Okay, let's just set the other two up. Even though the letters don't match up the same, you still have two sides not opposite this angle. So it's going to be 1/2, one of the sides times the other side times sine of the angle between them. Bang. And you would find that one there like that. You don't have to punch it in. We're just setting them up. The last one, same difference. 1/2, one side times the other side times sine of the angle. I know it is exciting. Other questions? Times sine of the angle, yeah. Any questions? Fantastic. So we're just going to move right on to the second part of today's lesson, which, much like the law of sines lesson we did in the beginning, which was quick because it was just that one formula, today is only one formula. And it's not like complicated. No. No. It's this formula. Write this down, and I'll explain it in a second. Yes. No. Just like the last formula we did, this is just the same formula written 3 times. You only have to write it once, and I'll just point out to you why they wrote it 3 times. But just write down that formula one time, and I'll explain to you why they bothered putting through it. These 3 formulas are the exact same thing. Only difference is, notice, well, let's see if I have another thing to write down. Great. All right. Okay, notice, if you don't look at what it equals, what does the right side of this equation use? It uses B and C and B and C, right? It doesn't use little a. The angle that you are given in these problems, the side opposite that angle is the one over here by itself, the little freak child. It's the one over here that you don't use in the formula. And that's the only difference in these. Notice, AA, BB, CC. And as long as you remember that the sides not opposite that angle are the ones you use in the formula, then you've got the formula. That's the only difference between those 3. Now let me show you why we need this formula. If you are given, okay, if you have a triangle, now, who can tell me, what did we have to have the other day to use the law of sines? You had to have at least one pair, right? Angle, side. Well, what if I gave you something like this? Something very similar to those area questions we just did. 6, 12, 100 degrees. Can you use the law of sines on this? Raise your hand and tell me why or why not. Can I use the law of sines on this? Why or why not? This is not a right triangle. It's generic. So I like where you had that. No, you can't. Why? Well, actually, the law of sines doesn't require a right triangle, but you don't. Yeah, again, I love all the chatter, but law of sines didn't actually work like SOHCAHTOA. Remember, law of sines was just built on angle side, angle side, angle side, just those pairs. Problem is, the only angle we don't have that side. And you had to have at least one pair to use the law of sines. So this is a classic example of when you're going to need the law of cosines. So let's look at one that I've actually pre-drawn up. So, once again, you do not have a pair. The word problems I'm going to leave for you all on Friday. You're going to have to figure out, that's going to be the only hard thing about them, is you have to figure out which formula to use. Always start out thinking law of sines or SOHCAHTOA. SOHCAHTOA fits a right triangle. This one's not. I have to throw that out. Law of sines. Do I have a side angle pair? No. I have to throw that out. So now I use the law of cosine. So, first thing I do, find my angle. Which side is opposite my angle? A. So that's the little freak that's over here by himself. Not saying that isolated things are freaks. Yes. I'm just saying that's the way to remember it. Okay, so then you take the other two sides. Just plug them into the formula. Minus 2b c cosine 46. And from here it's just a formula and you just plug everything in. That's right. So here we go. 16 and 64 make 80. Thank you. No, I appreciated that. I'm starting to think that was a dumb joke. Okay. Make 80 minus 4 times 8 times 2 is 64. Cosine 46. Please, hear ye, hear ye. You may not subtract 80 minus 64 because 64 is bound via multiplicative marriage to cosine 46. You cannot subtract 80 and 64. So, somebody actually punched this whole thing right here into your calculator. Awesome. Now just take the square root. I'm guessing 5.9. Yes. 6.0? 6. Now, thank you. Notice, it actually says solve the triangle. So I'm not done. I found this, but now look what I have. I now have a side angle pair, and I can finish this triangle with the law of sines. Now, if you did not like the last lesson we did, where you had to figure out how many solutions there are, there's ways to avoid that. What is the biggest side on this triangle? 8. So if there's going to be an obtuse angle here, which is where we run into problems using the law of sines, which angle will it have to be? So just solve for the other one. As long as you're looking for an acute angle, you're not going to run into any problems using the law of sines. So just find angle B, and then just subtract to find the biggest one. Just use that as a rule of thumb. If you didn't like what we did the other day, just always find the smaller angle.
So now we just need to find 46 and then
B over, yes. That's what we do to finish this problem. So to finish this up, yes, we would do sine 46 over 6 equals sine of b over 4. Somebody find b for me. Should be, are you in degree mode? You multiplied 4 times sine 64. Did you divide it by 6 and then took inverse sine? Are you in degree mode? Did you take inverse sine of it? I'll show you. What is it? Find the angle B. Okay. I've heard several 29s. I've heard a 13, a 0.5, a 17. I'm leaning towards 29 because I've heard it more often than the others. But I'm just going to real quick punch this in so I can feel confident about it. Not that I don't have confidence in you all, but I've heard like 18 different answers. Okay, so cross multiply. 4 times sine 46. Am I in degree mode? No. Okay, multiply. Divide by 6. Take the sine inverse of that. So about angle measures to the nearest degree. 29. Now just subtract. Add those together. Subtract. What is C? So interestingly enough, if you had tried to do the law of sines to find C first, what would it have told you? Somebody tell me what the calculator would have told you. Wrong. What? Who said it? What did you say? You're right, because it would give you the acute. I'm proud of you. Would you like a Reese's cup? Okay. Well, you didn't step up to the plate. I hope you can catch it. All right. Yeah, it would tell you 75. If you try to do the law of sines to give you an obtuse angle, it will not. It will give you the supplement. Good. That's why I just avoid that altogether. Muchos gracias, everybody. Good job. Okay. Well, more or less, but there's just one or two more examples we probably want to look at. Okay. We don't have to do this one. It's going to set up the exact same way. Exact same way. Law of cosines to find this little piece. And then use law of sines to finish it up. You all try this one. You can eat that in here because I gave it to you. You all try this one. Solve for everything. I will come around and assist. And then we will take the popular answer. And regardless of which one it is, the side you put by itself will be opposite the angle. Let's go. You're solving for angle A, angle B, and side C. Side C is the one you have to start with. How can I de-squeak my shoes? Better at hoodies. These were left in here when I found this last week. I was just like, I don't sleep at all. Put a zipper over that. Everybody looks pretty good, by the way. That's the one that went before. They didn't wrap around your belly. Did you have the sword? Cool, man. My sword's in the devil. No, hey, finish it. What? I have no idea what I'm doing. We'll go over it. I still don't know what I'm doing. You just don't know what I'm doing. Okay, I'm getting on. It's okay. When you do the second half of the equation, if you got a negative number, that's okay. Because it's just going to be 52 minus that negative number, and you'll get a bigger number. I believe it says here's 10 for the side. Here's 10. Yes, I'm thinking that. Yes, it is. Anytime you use that word, yep. Good. Good question. Someone asked if your answers will vary. They will only vary if people put in the trig functions at different times. For instance, if you did cosine 96 in the first step and then rounded that and multiplied it by other things, your answer will be different than somebody who just waited to do the cosine until the last possible second. So they should vary at most by a few tenths. If it's more than that, then somebody, maybe one, but not more than that. I believe it says nearest tenth, and I forgot to say that, so don't worry about it. Yeah, well, that's because the more you round, Devin, the more it's going to throw off your numbers. Everything. Tenth. Sides to the tenth. I believe I'm hearing 7 point something. 7.6 is. I'd avoid rounding that much. In the directions, I know there's no directions on here. It says to the 10th, so there you go. Okay. Did anybody get something very different than 7.5 or 6 for that side? What did you get? You forgot to take the square root. Remember, the whole equation equals something squared. Yep.
I got 7.439.
Oh, you got the same thing. Okay. Now. Yes. 1 second. Is there a chance? Is there a chance that either one of those angles is going to be obtuse? No, because we already have our obtuse angle. So it doesn't matter which one you go for. Who found them? Kim, what'd you get? Very good. She did the law of sines. She got C, and she took sine of 96 over 7.5-ish equals, which one did you solve for first? Whatever. Just go. That's fine. The angles say round to the nearest degree. The sides say to the nearest tenth. Okay. Questions about anything we did there? Okay. Only other thing we need to look at. There's one more scenario where you're going to need to use these. There's one more scenario you're going to need to use this formula. Ladies. And here it is. The law of cosines will also help you find angles if you have all three sides. Again, let's just be smart and look for the smallest angles. Actually, this is an isosceles triangle, so you know two of them are going to be the same, so you can skip a step there. But nonetheless, which angle does somebody want to find? C. Okay. Which would be A? Well, okay. Here's the thing. If you found... That's true. Once you have one, because it's isosceles, you can just use logic to find the other two, regardless of which one you use. C is the first thing I heard, so that's just what I'm going to go with. Okay. So we're looking for angle C. So which side goes by itself? Side C. Very good. So C squared equals... It is. A... What is C?
C is an angle.
Or look... I see what you're saying. At the end, it's going to be cosine C. That's the angle we're looking for. So, A squared or B squared plus A... you're fine. Minus 2 not yet. Minus 2 times the other two sides, cosine C. And we're looking for big angle C. Now, again, you cannot subtract on the right-hand side. So that's 64. 64, 36 is 100 minus 96 cosine C. You cannot subtract. It is bound by multiplication. You have to subtract the 100 first. Negative 36. It's not a big deal that it's negative. That's right. Divide by negative 96. What is that as a fraction? It doesn't matter. I'll just leave it like that. Which now those will cancel. So now you just take cosine inverse of that. It can't be added or subtracted, but you can divide it away. Like 2x. You couldn't subtract the 2 from the x, but you can divide it. Okay, you were thinking way too adulterer-ish. But yes. Every time I make a marriage reference, people always throw adultery in my face. All right, was it 68 degrees? Okay. I don't know. So, what is the other 68 degree angle? B. And we can just subtract to find A. 44. I'll show you. All right. Do you get where this step came from? All you have to do now is take cosine inverse of that fraction. Cosine inverse, I'm just going to go and throw out the negative since they're going to cancel anyway. Enter. 68 degrees. No, that was to find the first one. They were asking where that came from. Okay. Yes. Things you will know if you are wrong if you have done something wrong. If when you take cosine inverse, if this fraction is greater than 1, like 100 over 50, you've done something wrong. Cosine can't be greater than 1. It's based on the hypotenuse. So, you'll know you've done something wrong if this fraction is ever greater than 1 after value. So, questions about how we did that? We'll just set up the next one. And well, it doesn't matter. The next one's not, so we'll just look at that one. Okay. Braden, which angle would you like to find? There is a wrong and right answer to this question. Yes. Okay, very good. Just avoid the biggest one. Okay, so which side's going to go by itself? That's right, C. So 3 squared equals 4 squared plus 6 squared minus 2, 4, 6 cosine C. You're going to solve it the exact same way. You don't have to do it right now if you don't want to. You're going to find C, but this one you can't use that same kind of logic. So once you have C, then you're going to have to do the law of sines to find one of the other angles. There's no other way to do it. I mean, I guess you could do cosines again if you prefer it. But you are going to have to do something again to find angle B, and then you can subtract to get angle A. You might have a word problem in your future. You might have a word problem, and it's not going to warn you about anything. It's going to show you this kind of picture, and it's going to say, I don't know, I'm making a word problem up. Find the length of the flight or something. And it'll say find the angle of the reference or blah, blah, blah of the flight. You're going to be looking for this. On a word problem, if you are looking for this and your calculator tells you 40, what should you just assume the correct answer is? Very good. 140. That's what we did on Monday. When you are solving a problem, like let's say you just started off on this one looking for A, and it told you 40, you can use logic to say that's supposed to be obtuse. That must be one of those ambiguous cases. And then just subtract it from 180, and that will be the actual obtuse angle. Questions? That's all we're doing. Oh, here's some. The only difference is it didn't give you a picture, but it all works the exact same way. Yeah, you can just draw the picture. There you go. Yes. I think that's 14 problems. Yeah, yes. Well, I'm just now getting the most recent start. I can find my grade book, I can. This is 6.2. 6.2.